This is complicated. I'm trying to figure out how to improve the flexibility of my finger so I can actually control our lights, the different intensities of our lights. And it's really hard. I've been practicing all night and I still can't get it. Take a look at our circuit right now. This is a circuit right now that we have, and here are those 3 buttons that I've got to control. We have our LEDs over here. I've also wired up the meter so we can see all the current that's going through. I'm going to just move this out of the view of the camera because these LEDs are a little bit bright. So just so I don't, get it too bright on the screen. Now take a look at this. I have to do this calisthenics with my fingers to do this. Let's try it. Here's the first one. Next. And then this and this. And the next one should be the maximum. That's it. Maximum intensity. No. There we go. There's the maximum intensity. There's got to be an easier way. By the way, if you're wondering how we got to this circuit so far, make sure you look at the previous videos. I'm going to put a link for the playlist. Okay, so we've got a number of episodes already, and if you want to catch up on those episodes and it'll get you exactly to where we are now so you can see the circuit that we've built up. But regardless, I've got to find an easier way. And I think if we perhaps draw this out as a little schematic or as something that we can, visualize this pattern, we might be able to figure out a better way to do it. So let's do that. I'm going to move this aside and you're going to see I've created a little bit of a drawing here so you can see how we go. So here are the 3 switches that we had in our circuit before. There's switch 1, which is supposed to control the 50 milliamp current path. Here's switch 2, the 100 milliamp current path. And here's switch 3, the 200 milliamp current path. And different combinations give us the different intensities of the LEDs that you just saw. Let's take a look at the first combination. Of course, the first combination is all off. That's why I have this little yellow shade here indicating that these buttons are not pressed. And of course, with no buttons pressed, I'm supposed to get 0 milliamps. We're calling that intensity level 0. Next intensity is where we press switch 1. There you see that little blue that indicates that I've actually pressed that switch. This is intensity level 1. I'm supposed to get 50 milliamps. There's the next pattern, where we actually just release that switch and push switch 2. And then the following one is where we have these 3 set up, or we have 2 switches set up and we end up getting intensity level 3 and so on. There's 4 where switch 2 finally makes an appearance. And if we continue and take a look at all the different intensities, there we go. We can see that we got 8 different intensities, numbered 0 through 7, all the way from 0 to 350 milliamps. And these patterns of blue and yellow are the funny combinations I was trying to do with my fingers. As I said, it's complicated. I want to try to find an easier way. And I think we do have an easier way. And it's the tool that I'm going to introduce here. It has the coolest, in my opinion, the coolest name in all of the electronic devices. This is the simple yet versatile flip-flop. Oh, I love it. I could say that forever. Flip-flop, flip-flop. It's the coolest. Anyways, this flip-flop is going to allow us to create this pattern. Let me explain how this flip-flop works. All right, so imagine for a moment it's the middle of the night and you are feeling a little mischievous. Okay, so your bedroom window faces directly into your neighbor's window. And so the way we do this is, imagine you're going to be the instigator. So you're going to keep your bedroom light is off right now, and then you quickly turn it on. When you turn that bedroom light on, your neighbor sees the light turn on, and immediately your neighbor's got to get up, go to one of the, let's call it the primary bedroom. So bedroom A, and he's got to toggle the light in bedroom A. So let's say the bedroom A light was off. He's got to go turn that light on. Then he's got to go to bedroom B, and that light, which would have been on, he's got to now toggle that off. So he's swapped the position of both of those lights, and then that person goes right back into bed and waits until you turn your light off and turn it back on again. And that's going to make the neighbor wake up, go to bedroom A, toggle that light. So if it was on, he's going to turn that light off, then go to bedroom B, and if that light was off, he's now going to turn it on. And this process will continue as long as you keep flicking your light on and off. Now imagine that house has another house after that. And let's say bedrooms, I don't know, we can say bedrooms B's light is going into another person's room. And whenever that bedroom B's light goes from off to on, it wakes up that next neighbor, and so on and so on. You can string these houses together. And if you can imagine, if you want to sit there in your bedroom and turn your light on and off, then your neighbor is going to, every time that light turns on, he's going to wake up, toggle his lights, go back to bed. And then the next neighbor is going to do the same thing. But the neighbor number one is going to wake up and go back to bed with every second flick of your light, whereas the next neighbor is going to do so at half the rate of the first neighbor, and the following neighbor is going to do so at half the rate of the first neighbor. And so this trickle down effect is slowing down the rate at which the neighbors wake up and toggle their lights. So aside from being, I don't know, an extremely torturous method of sleep deprivation, it's pretty much, at a very basic level, how flip-flops work. And that, what I've described in words, is kind of the way that this pattern accumulates and starts to ripple down over the switches. So in order to make this work, I'm going to actually wire up this flip-flop. And this particular chip that I have here, this is actually, in case you're wondering, it is it's part of the 4000 series of logic chips. And this is the 4013, so 4013. That's if you're interested. You can pick up these logic chips and has a flip-flop. This particular chip actually has two flip-flops in it, so it's got two houses based on my analogy. And of course, since we have 3 switches in our circuit, 2 is not enough. I'm actually going to need another one. So that will give us, well, a total of 4 houses, but I'm only going to use 3. So these 2 flip-flops, or these 2 chips, are going to give us the 3 flip-flops we need to make this pattern, to actually affect this pattern. So I'm going to wire this up. You can watch me do it. And it's done. We've built it. That was a long build. There was a lot of wiring and a lot going on there. I didn't actually show the circuit of how these the 4013 chips are designed in the pinouts. But if you're interested in it, let me know, and I'll see if I can share some more information about how I put this up. But if astute of you actually followed along that video, which was pretty fast, I know, you may be able to follow along. The other thing you probably wondered is, well, what the heck is all of this going on over here? Because if you remembered, this part over here on the left, these 2 switches and all this conglomerate stuff over here, it wasn't in our original circuit. And I put them into this circuit a little bit in advance because I needed to do 2 things. The one on the left, this button over here serves as a reset. These flip-flops, remember, they toggle states, so they have their light on and off and on and off. And this button over here allows me to reset all of the lights to the off state, which means we're starting from fresh. And then this other button over here, this is me being mischievous in the bedroom, right? So this is the one where I'm actually turning the light on and off, and I need a way to actuate that. And so that's what this switch is for. It is for me to turn the light on and off. All right, so let's explain what I've done here. I have this little, this one green LED here. This is my indicator LED. This is the LED that indicates whether the the initial light in the bedroom is on or off, and right now it's off. And these three lights are the rooms in the neighbors' bedrooms, right? So the yellow ones in the bottom are the bedroom B, and the blue ones on the top are bedroom A. Basically, what I've done is I've wired these up so that bedroom A is connected to these switches, and I've bypassed the switches. In other words, if one of these LEDs turns on, these indicator blue LEDs, that means that this switch is active. I could remove that switch from the circuit, and I will eventually, but for now I just left it in there. This blue light turns on, that switch is active. So this is essentially the same as pushing that switch. That's what we've done here. The only reason I've included the blue ones is to show you when they're off. So this is kind of like the other bedroom. They're not actually needed in this circuit. They're just there for visualization. So let's see how this works. If I push this button, what that's going to do is that's going to turn on the first light. And watch what happens when I do that. It turns on. And this light then turns on. So what that means is our first neighbor has woken up and turned on his bedroom A light. And of course, bedroom B light is now off. Now, when I release this switch, this light now turns off. So now I've gone back to bed, and so has neighbor one. And when I do it again, this neighbor one gets up and pushes his bedroom A light down and puts bedroom B light on. But when we do that, that signals the second neighbor to go and do that because he's looking at this yellow light. The second neighbor is looking at bedroom B light. And so he wakes up and turns his light on. Now I'm going to do it again. And so I go ahead and I turn bedroom A, or the first neighbor's light, back on. But see, bedroom B is still sleeping. Neighbor B hasn't woke up because that light has not turned on yet. Now I'm going to do it again, and this light's going to turn on, which is going to cause neighbor B to wake up and toggle his lights. But by him toggling his lights, neighbor C has now woken up, and that light went on. And I can keep going, and you can see how the pattern adjusts until all the lights are on. And at this stage, we're now at intensity level 7, and the lights should be at maximum. Of course, I've disconnected the lights. That's why the lights are off right now. But once I plug them in, you should be able to see them turn on. Also, I didn't actually quite explain why I have all this other stuff up here. I don't really want to get into the details, but put simply, physical switches are messy. So when the metal contacts inside they touch, they tend to bounce a little bit. So what this is up here is this is a debouncing circuit. Again, I'm not going to get into the details right now. This is going to become more important in a future video, which is when I will explain what the heck is going on with this debouncing. But the other thing is, after you debounce it, you actually have to then buffer it so that these switches identify that as a nice on switch. So again, don't worry about the details. We're going to get into that in a future video. But for now, just assume that this allows me to clean up my switch. So that's what's happening. If I keep doing this, you can see the pattern that we're trying to create is successfully being created here. I love it. Now, let's plug in the LEDs and watch what happens. So once again, I will move this up out of the way a little bit so it doesn't, it doesn't blind us. And then let me plug in our meter, which will also monitor the, well, of course, it'll monitor the current going through our LEDs, but it'll also let us know that the LEDs are working. So let me do that. Oh, look at that. They're actually on right now at full blast. So I'm going to hit the reset button to turn them off. So now they're off, and let's go through each intensity level slowly. So here's intensity 0, and we can see 0 on the meter. There's intensity level 1, and we can see almost 50 milliamps on the meter. Intensity level 2 should be 100. Intensity level 3, that should be about 150. Here's intensity 4, which should be about 200. And there's intensity 5, this should be about 250. Intensity 6, which should be about 300, and intensity 7, which should be about 350. Now, if you remember from the previous videos, you know why I'm having a bit of a loss here. It's because of all the losses in the breadboard, etc., the big long wires. We're going to put this on a prototype board in a future video so that it actually gets closer to the right result. But it worked, didn't it? We got our gradual increase, and I didn't have to do all this stuff with my fingers. All I got to do is push this button repeatedly and watch my intensity change. Success! That's a whole lot easier than trying to figure out how to do it with a bunch of finger patterns. Next, I think I want to make it faster. Until then.